All right, for 410 notes, we're looking at triangles inside triangles. So let's do a review problem so that we can relate it to the little bit tougher problems with the triangles inside triangles that we will do today for these notes. Okay, so here's the first thing I want you to do, always for triangles inside triangles. And that is find the two triangles we're talking about. So don't draw this. I'm going to erase it in a minute. Notice this first triangle. That's the one I'm hoping you're noticing. That's the small triangle. And then in a different color, the big triangle in this picture is that one. Okay. Now between the red and the blue triangle, both of those, what angle is in both of them? Okay, so again, don't draw this yet, but I hope you're going to tell me angle C. So remember, I put 2 marks, meaning it's in both triangles. I hope because of the parallel lines, you're also going to tell me that there are at least 2 other sets of angles that are equal because they would be corresponding. Okay, you only need 1 set as you have seen in the past videos. So I would say those 2 angles are equal. Okay, that's the first way. So I'm going to go ahead and get rid of that. Like I said, that's the first thing you do in every problem. So once again, it would be sitting like this. If you're visualizing the 2 triangles, you're going to mark this. So now you should put this in your picture. Angle C is in both triangles, and these 2 angles are equal and corresponding. So use a different marking. Now notice, I'm going to again erase this in a minute, but these 2 angles could have also been marked the same, right? Those are also equal and corresponding. But remember, for angle, to prove triangles are similar, I only need 2 sets of angles, okay? All right, we're going to use this to help us with the harder stuff. So here's what I want you to do always. Always draw the small triangle and then the larger triangle, right? They're not exactly the same, they're similar. So that's why I am purposely making them look different. Draw the small triangle exactly as is. And that means every single label and every single marking. 6, 2x, and 8. At this point, go to the big triangle that you're creating, this one, okay? And don't even look at the original yet, but go to the one you're creating and make it look the same as this one with markings. That's what I mean. Put them in the same place so that if somebody flips the triangle around on me, it doesn't do anything. Okay, it doesn't confuse me. All right, so I put the markings in the same place. Now, in the big triangle that we are working in, I ask myself, looking at, again, this original picture now, I'm just going back and asking myself these questions. Where is this double mark in the big triangle over here? It's at C. Okay, where is this single mark? This one. Over here in the big triangle. It is in letter E. And what is the other angle that's not labeled in the big triangle? It's labeled A. Okay. Now this will seem pretty simple because our 2 triangles happen to be drawn in the same direction. But remember, we're practicing this for when they are not. So you should now go to the big triangle once again, the one we're drawing, and just ask yourself about the sides. What is the length of AC? Well, I'll come over here in this picture and I'll look at this. And I'll say 9 plus 6 is 15. Then I'll say, what's the length of CE? All right, well now I'm going to look at this length, which is 2x plus 18. And then I'll ask myself, what's the length of AE? And I'll look at this length from A to E, and I'll say it's 3y minus 1. Because you guys are, I'm just going to get rid of this extra stuff for a moment. You guys are good now at going when you have 2 pictures. Okay, going and making similar triangles, setting them up. But let's practice. So remember, again, the kinds of questions you would get. Are these similar triangles? And you know you just set them up to be similar triangles. But if you had to justify it, you're going to tell me that these are similar triangles by angle. Okay, two sets of angles equal to each other. Map them in the correct order. The first one's always alphabetical, so first one I always consider to be on top, or the one most to the left. Maybe for us it's going to be the smallest one, so I always say put the small one first. All right, so it's going to be triangle BCD is similar to triangle, matching the markings, it would be ACE. Okay. If we do our lengths, make our three fractions, we would have 6 over 15 equals 2x over 2x plus 18 equals 8 over 3y minus 1. And don't skip the step that I did. If you need to write BC over AC equals CD over CE equals BD over AE before you put in the numbers from the pictures, do it. Okay, I don't want you missing it just because you're trying to skip a step. Don't do that. All right, so as far as fractions and analyzing, looks like I will take the first two fractions with each other so that I can solve for x, because it's all x's in numbers. And cross multiply, so let's see. If I distribute 6 to the quantity of 2x plus 18, we'd have what? 12x plus 108. 15 times 2x is 30x. If we subtract 12x from both sides, 18x equals 108. Divide by 18 on both sides, and x will be 6. Okay. Then, if we go ahead and do the first fraction with the last fraction, 6 over 15 equals 8 over the 3y minus 1. So we have all y's. Distribute the 6 to the 3y minus 1. That would give us 18y minus 6 equals 15 times 8, 120. Add 6 to both sides. 18y will be 126. Divide by 18, y will equal 7. Okay, you're finished with 1. Now notice, in 2, and we're going to use the same process that we used on that one. In 2, we're going to say, hopefully we're going to notice that they're not sitting in the same direction, right? I don't have parallel lines this time. I clearly see that this dot is kind of on the left side of the small triangle, but it's in the right side of the big triangle. That means somebody's just flipped it around, okay? Turned it around, turned it upside down, possibly, and put it inside the picture. Our goal is to get it to look like the same, like we did in 1. Notice both triangles look the same. That means ultimately, guys, really the shortcut I'm trying to get you to is this. Right here, remember me saying, don't miss this because you don't put BC over AC, so on and so forth. But guys, if these two triangles, these two, are sitting in the same direction, meaning the markings are in the same place, can't you just say the left side over the left side, notice 6 over 15, equals the right side over the right side, notice 2x over 2x plus 18, equals the bottom over the bottom? If you have them sitting in the same direction, that would be a nice shortcut for you, okay, to be able to utilize. So keep that in mind. That's what my whole goal is to make them look the same. And by that we mean have them in the same direction. So number 2, here's exactly what I do when I come to a problem like this. The very first thing you should do, ask yourself visually. I hope you see the small triangle with letters T, A, and H, and I hope you see the big triangle with letters T, M, and S. Okay? Which angle is in both of them? Well, literally the angle letter that you just said twice is T. That's all it takes, because guess what? They already marked the other set of angles for us. Okay, that will now give us 2 sets of angles. Your job is to always take the small triangle and draw it exactly as is. Okay, just do your best. It doesn't have to be a perfect picture, but including the labels. So A, T, H, the 7, the 9, x plus 3, the double mark here, and the single dot there. Okay, so literally copy everything. Now, draw a bigger triangle that looks just like the small one. And by that, we mean put the labels in the same spot. Okay, the markings for the angles, if you will. That's what I mean. And now ask yourself from the original picture given to you, in the big triangle, where's the double mark? Well, the double mark is sitting over here at T, so I'll put T there. Ask yourself now, in the big triangle that was given to you, where is the dot sitting? Well, notice the dot is sitting here at S. So I will label this S. And by default, guys, what's the only other angle in the big triangle that's not labeled? It is M. So I will label that M. Okay, so it's really about you asking yourself the right questions and taking the information from the picture. Now the same thing, okay? Remember, they're in different directions, but I could care less. All I read are the labels. So for instance, if I want to find this length, SM, I go to the big triangle, I find S, I find M, and I notice that there's 18 between them. Okay, that's it. Next, if I want to find the length of ST, so let's do this one, this whole length, right? Then I'm going to go look for S to T, and I notice I see x plus 3 plus 9. That would be that length. If you combine x plus 3 plus 9, you will get x plus 12. Okay, I think hopefully you're catching on to that. So maybe I won't draw the last arrow. Last side is TM. So I go and look in the original picture. From T to M, I see a 7 and a Y. So I need to do 7 plus Y, or Y plus 7. And there we go. Everything is labeled. Now notice, I can go ahead and start. Move this so we have a little bit more room. I can go ahead and start asking myself and proving the different things. So these triangles are now similar by angle, angle. Notice they have two sets of angles that are equal. You can map them. First one, the small one alphabetically would be triangle AHT, is similar to triangle, match the markings. It would have to be SMT. And now, if you'd rather do letters and take them off, you're going to do AH over SM, HT over MT equals AT over ST. However, here's what I was saying. If your two pictures are drawn exactly the same, notice they both have the dot on the lower left, they both have the double marks in the top. Can't I just go straight to saying the left side of the small one? This is like when we were writing our proportions, right? I'll say small triangle to large triangle, if that will help you remember to always put the small one on top and the large one on the bottom. Just be consistent, okay? So you could say the left of the small over the left of the big one equals the right side of the small and I know there's kind of like a right, let's say the bottom of the small one over the bottom of the big one equals the right upper part of the small one over the right upper part of the large one. Okay, to me, I'm just looking at the picture now and copying it right off there, and I'm skipping that step with the letters. Okay, unless somebody is telling me to write the proportions using the names of the sides. Okay, all right. So then, now that we've written that, we're going to solve for x and y. And this is what you've been doing since the start of the chapter. So thinking smart, you should probably put, let's see, I don't want to do x and y if at all possible. So I'm not going to put the second one with the third one because that would have x and y. But if I put the first one with the second one, notice I will have only x's and numbers. Okay, so I only have one variable. Perfect. Let's cross multiply. 9 times x plus 12 if you distribute would be 9x plus 108 equals 7 times 18, 126. Subtract 108 from both sides. 9x will be 18. Divide by 2 and x, divide by 9 and x is 2. Now, when I go back and solve, 9 over 18 equals x plus 3 over y plus 7. No choice but to use that last one so that I have y to be able to solve for. Well, then that involves you just making sure that you found the x first, and now you're bringing it up here and plugging it in for that x. Okay, so we're really looking at 9 over 18 and 2 plus 3 over y plus 7. I'm just showing you every step to make sure you're still with me. So we're talking about 5 over y plus 7. All right, now you're ready to distribute. 9 times the quantity y plus 7 distribute would be 9y plus 63. 18 times 5 is 90. If you subtract 63 from both sides, you will have 27. Divide by 9, and y will equal 3. All right, why don't you try this one yourself if you feel comfortable. Turn off the video and then come back and see how you did. All right, so hopefully the first thing you should have thought of is the following. 1, which angle is in both the small and the large triangle? The small triangle I see has letters M, O, and T. The big triangle I see has letters M, E, and G. And literally, the letter you said twice was M. I notice I already have right angles drawn for me, so I don't need any other angles. You're supposed to draw the small one exactly as is, doing your best. Copy all the labels, the lengths of the sides, and all the correct markings. There we go. I'm supposed to draw a bigger triangle that looks like the small one. Okay, so do the best you can. Remember, we trust what the picture is labeled, not necessarily what it looks like. Okay, but immediately I'm going to go and put my markings in the same place as the small one. There's the right angle, there's the double marks. Ask myself those same questions from the original picture in the big triangle. It's either M, E, or G. Which angle has the double mark? Oh, it's at M. Which angle has the right angle? E or G, that's all that's left. It's G. And which angle is not labeled at all? It's E. Okay, so now I go and ask myself the length questions. What is the length of E to M? Well, E to M has 11 and 4. 11 plus 4 is 15. What is the length of EG? EG is labeled as 9. In the original picture, the length of G to M has y plus 3 plus 5. So y plus 8 if you combine those. All right. And then, of course, our typical work. Are these similar triangles? Yeah, that was what you were doing at the start. You were making them similar by marking the angle that's in both. So they are similar by angle, angle. Two sets of angles are equal. Triangle, the first one, the small one, alphabetically would be MOT, is similar to triangle. Now match the markings. MGE. Okay, again, I'm going to go with my little bit of shortcut. If you want to do letters, MO over MG, OT over GE, MT over ME, go for it. But now that I have my triangle sitting in the same direction, I'm going to say the left side of the small over the left side of the big equals the bottom of the small over the bottom of the big equals the right side of the small over the right side of the big, which gives me those three fractions. And now I'm just set and ready to go. Okay, I'll take the first two that have only x and constants, cross multiply. So 15x equals 45, divide by 15, x is 3. And I will also take the second fraction and the third fraction, put them together since they have only y, distribute the 5 to the y plus 8 quantity. So 5y plus 40, 15 times 4 is 60. If you subtract 40 on both sides, let's have 20, divide by 5, and y will be not 5. Sorry about that. Y will be 4. There you go. Okay. All right, so that's really the main last concept to get down, guys, for this chapter. So get that mastered and be ready to ask any questions. Good luck.